Hello there. Today again we are going to start a new topic called Basic Structure Modeling of Unit 4. In this one we are going to see class and its relationship, common mechanism diagram and class diagram. I have got about 28 to 29 slides. It will be long. Let's see it's how fast I can able to cover it. First, we have already seen class diagrams. Describe the set of objects sharing the same attributes, operation and semantics. Meaning, correct? Semantic means meaning. Abstract, which is given abstracts of the thing that is part of a domain with vocabulary. If I see any vocabulary, I can able to tell that's abstract. Like if I say student, that is archetypes. If I know what you mean by student class, I can able to tell what are its operation, and it's represented by this one: shape, attributes and operation. Correct? The names, noun, draw from the application domain with very good vocabularies. As we have seen, the rules, the name should be perfect, beginning with a capital letter, and it should short of meaning also, like shape, yes, temperature. And this is a path name we can able to give in the packages. That's different things. Attributes, name, properties of the class. I can able to give like this: customer with the name, the date of birth. I can able to define the data type, so that whenever I am entering a data, it's very useful for me. Extension of a class structure, type and default values. Then terms and concept of this: what are the operation which can be implemented? Implementation of it's nothing but behavior, that is dynamicity of the message can be understood, like add, grow, move, empty. These are all operation, or I can give a meaningful definition also, operation of this one. Correct? Reset, set alarm, T is equal to temperature, volume, value, what will be the temperature of it. Again, terms and condition, organization, attribute. Stereotypes. What do you mean by that? Which is not been used. Suppose an example which says that this every time if the room temperature goes up to 30 degrees, there should be alarm. So once the alarm goes up, you can able to tell it's 30 degrees. So that is a stereotypes. Means you can able to understand why it is the temperature reaches 30, it goes up. For an example, there are some students which are always absent. So you can able to tell them with the stereotype, this student will always be absent. Correct? And let's other type of that, there are some important questions. This question will always be asked. That is something stereotypes. Definition, meaning or behavior of that one is given to it. There are some attributes which are stereotypes which you want to use it or you can omit it. Correct? This is the part. When the model can define the class, are they abstracts? Are an abstraction for something can be drawn either from a vocabulary or something like that. When you draw a class diagram, show only the properties, correct, of the class that are important to the current context. Correct? And organize the list of attributes which are available. Show the related class in one group. Responsibility. What are its responsibility? Define the requirement of the class. Express the context-free text. What it's going to do. Can be used early stages of abstraction. Correct? Now, common modeling techniques. Modeling of vocabularies. Identify the things that user can able to describe the problem, that we can use as vocabulary. Identify things that are implemented to describe the solution, we can use as vocabulary. For each class, identify the set of responsibilities. What are its responsibilities? Define the requirement of the class on all those things. Provide the attribute that operation needed to carry out for particular responsibility. Aggregate the related to cluster into package. This is the part of vocabularies. Then modeling the distribution of responsibility. How you are going to distribute the responsibility. Identify the set of classes that work together to so that they can put in one place. Identify the set of responsibilities for these classes. If there are three classes of same, what are its responsibilities? Aggregate the class that has too few responsibilities. If few responsibilities are there, I can able to aggregate. Split the classes too many responsibilities. If there are too many responsibilities, you split that one. Consider the workload environment. These are very important points. So if you have too few responsibility, you can able to aggregate. If you have few more responsibilities, you can able to split that one. Then a relationship. What do you mean by few classes can able to stand alone? But there is a relationship between. That is called dependency, generalization, association, interaction with. There is a window that is dependent on event, correct, which is represented by dotted line. Open, event has opened and the class will changes, correct, and close another. Generalization, console windows, dialogs box. There are windows, there are two types of windows which are available. That's why we have got two topics. And this dialog box is control, is associated with something called remote one. And dependency can change the state of an object, may affect the behavior of the object. If it is dependent, it can be changed the effect of the dependency. A class uses another for its behavior. Yes, it's there. Draw it, it is drawn by dash dotted lines like this. If you have seen it like this, correct? And more important thing is that most often used to show one or more operation in an argument. Dependency can be used at various level of abstraction. Terms and concept of generalization, correct? Relationship between general things, parents and more specific children. Parents and children are defined. Children inherits the attributes. The attributes from here can able to be defined in children. And operation can be redefined or overwritten in children, and that is concept of polymorphism. Operation can be redefined in children. Now let's move on. This is what? Shape. This is my superclass which is represented by this one. This is my generalization. Rectangular, circle and polygon. A radius, it is overwritten. Operation in children can be overwritten. Point display is already there and I can able to do something like that. The major part is that in children the what you call the operation can be overwritten. Then we have got one more. Bank account, saving account, credit card account is a part of this one. We go more, it is called generalization. This is top down approach. Top down. When you get down, it's the bottom of approach. It is more specialization. Account, which account you got? Credit card, specialization. Account, which account you got? Saving account, it is specialization. Terms and condition, association. Association used to show the structural relationship between them. Correct? Draw a solid line like this one. Describe the nature of the relationship, can include the direction of the relationship. Draw in the middle of the association. Person work for an organization. Person is associated with an organization. That is part of it. Correct? Like student is associated with the structure. Two class model communicate with each other. The link between can be represented by association or connector. A single student can associated with multiple teacher, or this example indicate every instructor has one or more student. This is one to many, many to one, and sorry, this is student to teacher. What do you mean by this one? We'll say you. Student learn. This is also a part of this one. Correct? This example. Now, these are all example. Passenger in a plane, association, direct association. If this is one, this is. It is called a reflexive association. Passenger to aeroplane. This is called multiple. One aeroplane has n number of passengers. This is aggregates. I'll able to tell you this one. This is composition. We will able to see this one. This is inheritance. Bank has a fixed account. This is realization. Printer setup, then only we can able to do the printing. We are not going to use more this one. We are not going to use this one. We are going to this and this. Correct? These are different diagrams which are specified this one. Aggregates is association. One class is a part of other. Has a. This is aggregation. Book is in a library. Correct? This is aggregation. Department, many department in a company. That is engineer. Engine perfection, car. Engine is a part of engine perfection. Engine is a part of a car and wheel. This is has a relation. Important. It has to be there. That is called aggregation. And common modeling technique inheritance. Some class will have common behavior. That common behavior tell us superclass. Given a set of classes, look for responsibilities, attributes to our own classes. Evaluate them with general class without introducing many levels. Specify the children's inheritance with the parents. Multiply the inheritance with them. The major part is that common behavior we are going to take it. Common modeling techniques, relationship. Each pair of a class, if we need to navigate between two, define the association. There should be association between two class. Each pair of class, if an interaction is needed between two, other than parameter operation, specify the association between two. Behavior association. This is data driven association. Navigate means data driven. If they are passing parameters, we call it as a behavior association. For each of these association, define their multiplicity. If one of the class is part of that, make it aggregations. These are very common points or important points. Diagram employs name, application, purchase, vehicle purchased by applicant, and applicant is a person. He may be employee. Correct? And this is a bank loan. All this a diagram which is a present. Credit card name is associated with. Means you are buying a car, maybe employee, then a person name. Bank loan, person loan application, where it is a part of loan application. Loan details and other. Bank executive will verify this. One person can submit n number of application. And on loan account, it can have one person can have n number of loan account. Credit card record, anti-fraud department is a part of it. What do you mean by this line? Just go back again. What is this line present? Correct? Composite. What do you mean by composition? Composition. What do you mean by composition? We haven't got through it. Correct? Composition. Now let's move on to there are other part. Common mechanism. Some important facts about design. About design might be not expressed basic UM. That is nodes, various numbers of component, constant and dependency. Nodes, a graphical symbol which cannot be a representation. Draw a rectangle with dog on corner containing a textual or graphical representative. It does not carry any sentiment impact. Tag external properties of UML. Brackets you can able to tell. These are very important points. Stereotype extension of vocabularies in UML. We have just discussed use of creating new lines. We can able to do the guidelines we can represent. Constraint extension of semantic. Bracket. What are the conditions? Constraints are nothing but conditions. What are the conditions? You can able to do this one. Class diagram, most common diagram used for modeling objective. Show some class interface collaboration. Model is a static views, involvement, all those things. Terms and concept, class diagram, class interface collaboration, relationship, anything. Thank you very much. I'll stop it here.